he's joining us for some other field work from maybe 24th onwards. So it's a study spanned over just 3 months of time. We tried to look into different aspects of the arsenic testing in a part of Bihar. So just coming to, I'll be addressing few of the points, few of the say problems which are very much prevalent in these South Asian countries. And this is one of the interesting map that was actually given by Ravenscroft, and it's actually a map which shows that it is the distribution of population density within the South Asian countries. And in fact, you can see the red part, which is actually as developed, is the belt which is highly prone to arsenic contamination. And this red part, and in fact we concentrated on this smaller part which is shown by a green square, which is a part of Bihar. And looking at some of the literatures which currently cites the problem of arsenic, it is one of the paper by Smith which cites as the arsenic problem as the largest poisoning of a population in human history. Well, there are a number of factors which arsenic somehow affects. There are impaired intellectual function in children. There are different kinds of cardiovascular diseases. There are also chances of cancer due to arsenic contamination in water. And one of the key feature with this kind of contamination is it is very, very heterogeneously distributed. So I'll show how this distribution is. So you cannot actually pinpoint or predict a point where this contamination is actually taking place. And there are few number of interventions from different governments. They try to treat this groundwater based on some community-based approaches. We have seen in case of Bihar, the government of Bihar has somehow worked upon to supply treated water centrally to different villages. However, when it is seen on ground, it doesn't work out well. And since this contamination of arsenic, it doesn't change over time, and there are studies by Fendorf and Pitts that says that this kind of variation, the temporal variation in arsenic content of water, it doesn't change over a decade of time. So the essence of study, this study comes out is how can we minimize this exposure of arsenic by switching of wells, which are switching of from unsafe wells to safer wells. And as I said, there are a number of interventions which somehow has come as a failure. We'll be addressing few of the questions in this study. We tried to look out for, are the households willing to get their wells tested? However, this is again looking from econ perspective. We tried to test, it was a sort of revealed preferences, not a contingent evaluation method. And is there a market for arsenic testing in these areas? And what determines the household decision to switch to a safer well? Since there are some inferences from the study, but still we are not able to come up with a very concrete answers for these type of questions. And how could more switching to safer wells be encouraged in this kind of rural settings? Study design, just picked out randomly. We picked out 100 villages in the study area, out of which we looked for clear satellite images, so that these maps, these results were somehow have to be shown to the villagers. So we looked on to we had a criteria of 50 to 100 households in a village, which we again pointed out using only satellite data sets. And then we recruited few of the testers which were trained how to use those testing kits, and these kits are actually, they can give you the results on site within 10 minutes of when the water is collected. Within 10 minutes you can just convey the results to the households. What we did was we randomly assigned these 26 villages in category of rupees 10 to 50, and each 5 in each category of this rupees were assigned. And what we did was, initially we went to the village in the district. We took out 5 villages. We did a free testing all over, just to come up with something that we can show to the villages where we will be conducting our interventions. So we made maps for those, which you will see in few slides. And when we went to a village, we discussed, we showed the map without test results, so that those villagers could be educated whether they can identify their houses on the satellite images or not. When they were trained on this, that they could identify their individual houses, so then they were asked, we asked them that we will be offering the tests at this cost. So whosoever is willing to get their well tested, they may. We visited door to door for this kind of activity. And also these are 26 villages along with the data set for which the testing was done. And this is kind of activity we performed in the villages. These maps, actually you can see the blue points out there. These are actually the test results displayed on the map. And then the villagers were asked that, okay, these are the blue wells which are safer, and red wells were tagged using red flags, and we said that these are the wells which the households which are having red wells have a chance they can shift to a blue well of a neighbor of around his house. So these are the villages, and you can see these numbers are actually the prices we offered in these villages, and this is how we tested and then tagged these individual wells, indicating that the blue plates were tagged for safer wells. Since now the guidelines of India for drinking water has changed for arsenic. Initially when we conducted this study, it was 50 mg was considered under permissible limit. So now they have shifted to WHO standards, and then we tagged the unsafe well using a red flag. And this is one of the most expensive item, because these are the metal plates which are usually durable for 10 years. So this would be something that somehow may promote the households to look for blue wells which are safer for drinking and cooking. This is again few of the results from villages, and in fact I'll go into more details of these maps. This is how distribution of arsenic in individual villages there, and you can see, you cannot generalize that whether which side of the village would be having safer well or which would be having unsafe well. We tested, and we tested for. We actually asked few of the information from the individual households, but we also found some of the households which were not willing to share their information in terms of whatever the questionnaire we had. The response to this testing, which is a village where we have fixed the price of 30 rupees, which is nearly about 20 cents. And as you can see in this village, out of 9 unsafe wells where people were using this unsafe water, out of 9, 8 of them switched to a safer well. This is a quite contrasting case as referred to the earlier village. Here again you can see the distribution, the contamination of arsenic, and in this case we had charged 40 rupees in this village, and what we see is none of the unsafe well users tried or they were willing to switch to a safer well. They still are looking for clues that what might be the reason. Maybe Prabhat would be telling a bit more onto it.
This project was to capture how much demand is there at different prices. So following Kramer's paper, Kramer's and others papers in QJ, they showed that revealed preference methods are much better, more reliable for valuation of water quality, and they found that revealed preference methods give you like about 1/3 of the values which you calculate from stated preference method. Next, in arsenic testing literature, there has been many projects, and they found that once you tell people that the arsenic status of their wells, they are very likely to switch to a safer well. This is something like you have a public campaign where you tell people that there may be arsenic in well, and then people don't know what to do. But unless they receive the information about the exact status of their own well, they don't switch. In another paper where we follow self-reported behavior of switching to a safer well, and how much is that correlated with actual decrease in arsenic in content retained in body. So we have found in urine samples as well as nail samples that once people switch their drinking and cooking water sources, arsenic is reduced drastically. This is one of the major point in this study, that in Bihar we found much lower switching rate. In some of the studies, the switching rate has been found to up to 70% or even more than 70%. And in Bihar we found a switching rate of only 30%. So that raises some concerns, like what are the factors, like why people are not switching in that proportion. Finally, one more paper by our co-author Lex and his colleagues, where it has shown that like one-time communication, if you just tell people that okay, this is the arsenic status of your well, it's not likely to yield a higher switching rate, it's not likely to yield a behavior change, and that's why we do all this permanent tag thing and public awareness campaigns. So this is one graph, and I'm sorry, after this there will be some regression table which I will summarize. I will try my best to summarize. But in this graph, we can clearly see like how demand goes down. As we saw on x-axis, we have prices. So these villages, like 5 in each, and 30 rupees, there were like 6 villages. And we see like the demand in some villages, we had almost 90% uptake of testing at 10 rupees price. But once we walk on the x-axis, at 50 rupees, the demand can go down, and average was about 45%. Actual cost of testing is about rupees 140, 130. The idea was here to sustain a level where the tester can earn his own wage. So if you want to target a level of 70%, then it may be about rupees 20. And we believe that from public health point of view, from the policy point of view, if you can create a semi-subsidized market where you have people going door to door and testing these wells, and then that will yield a higher penetration. Like 20 wells testing in a day for 20 rupees will yield 400 rupees, which is kind of nice. So the same thing in regressions, and we see that as we go down and as we increase the price, the coefficient increases, and it shows that people are less likely to pay higher prices for this test. And there are of course some selection issues, like people who are paying these prices are more likely to be wealthy, and we test that, and we do find selection effect that the higher prices are highly correlated with assets of these households. We don't have much information, but these are some asset information we collected for these households. Now,
can you just go to the previous slide for a second?
Sure.
The one before that. So right at the bottom, if you tested some for free and then that led other people to pay for it. So when you tested some wells for free, other people paid for the test.
So no, we test all these are for some price. So there are no test for free.
Number of community wells tested for free.
Oh, so yeah, so I did not go into detail in that. So in each village, when we put the map of a sample village from outside of this 26 villages, we also discussed that we also told them that we will test all the community wells for free in the village, and we do so see that, like, once we tested for some community wells, depending on how many community wells we tested, we see a higher uptake rate in those villages. Yeah. So now, after this point, these tables are mostly like descriptive stat and correlations, and we want to see like what determines the uptake rate. So we found here in this table, what I'm trying to summarize is before purchasing test and ex ante, where people don't know what will the status of what will the arsenic level in their well, they do look at a number of wells nearby and whether they will be able to switch to a safer well or not. So it's something like, if I have made a big investment in a well, it may cost me $150, and then I really want to see whether I will be able to switch if I buy this test. And that's what we see, like in the first variable, like number of any type of well nearby affects significantly the probability of purchase. And for switching to a safer well, this is more just common knowledge that people who has more safer wells within a walking distance are more likely to switch. So we ran this regression, and we saw that, like, having one extra safer well increases the probability by about 2%. We had so the percentage. It's like we did a census of all the wells in these 26 villages. So there were 1,800 households. Out of that, about 60-70% household purchased test, and that was like around 1,200. Out of those 1,200, we got about 250 red wells. When we went for the follow-up survey, whether you switched or not, and then we could trace about 1,100 households. So there was attrition of about 10%. So this is a sample of the red wells, and we asked them whether you switched or not, and we see here that number of safe wells within a walking distance affects their switching decisions. And this also tells us, like, if government has to install community wells, they should look for more strategic locations. Just for comparison, we have a table from Bangladesh where we had a similar program, and the difference here is the same variable show a much higher effect on switching. It is probably because there is much higher level of awareness in communities about arsenic contamination. And on the top of that, in this project, Lax and his colleagues, they are also running a cohort program where people are given some sort of incentives that they have to give their urine sample over a period of time, and they will get in return free access to health clinics. And we have found that households who are enrolled in these cohort programs are much more likely to switch. So this gives a way for policymakers how to increase switching in these areas we have. We also find...
So the enrollment was for those who switched, that was an inducement to switch?
So enrollment was for highly contaminated, so yeah.
So that's a variable, that's a household level variable, whether a household actually enrolled or not.
Yes. Yeah, that's a level. So we also looked into, like, people who pay higher prices, are they more likely to switch? So in public health literature, there is there was this paper by Nawaz and others about sunk cost versus screening effect. Sunk cost versus selection, and where like if you invest a higher amount, then you are more likely to use that project. So here, this is not a product. This is more about information. Using the information you get after paying this price, and we don't find any that kind of effect.
This one is mixing together the screening and the selection, right?
Yeah, this one is mixing. Yeah, so screening is there, that we are sure, because we will see the same in switching behavior also. Now, so the last point in this presentation, last kind of tables, we suspect that some of the cultural issues may be playing a role and that's why we are not seeing, that's why we are not seeing that high level of switching behavior. So after everything was done, and we don't have micro data on caste of each household, but we tried to categorize the villages, and the paper I mentioned today by Sivan Anderson and others, like they found that people provide access to irrigation water based on like what is the caste structure that is dominated by backward caste or higher caste, forward caste also. So we categorize these villages as per like this cut of 80%, but this is fairly robust to 70% and 90% also. And what we see in the last column, in the last row, if you see that like the switching is like just 3 out of 42. This is like less than 10% switching in backward caste villages. The same thing, if we run the regression for purchase and we don't find any effect of caste, any correlation of caste with purchase probability. If we control for prices and everything in the last column, you can see. But same descriptive table, we can see regressions that backward caste dominant villages show consistently high and significant coefficient, even if we control for well and number of safer wells within a walking distance. So that's it, and let me just summarize the results. So first we found we estimated river preference. We estimated the demand for well test, and this is one of the first studies in arsenic well testing. Second, we find that household wells and number of wells nearby affect probability of purchase. Then switching rate observed is much lower than what we started what prior we had before, and we also find that like wells and number of wells nearby affect the switching probability. We see some evidence on the screening effect. Caste may be playing a role. We are not sure about that. This is more a descriptive stat, but we need to look more into it. And if there are evidences that caste is playing a more important role, then there should be some policy interventions there. For policy implications, we have a couple of points. The first is there is a possibility of subsidized market for arsenic well testing, and we also wonder whether it will be good from public health point of view, where we provide incentives to testers to go door to door and convince households to get their well tested. And importance of awareness campaigns as we compare our results from Bangladesh, and we saw that difference. And we do need additional efforts in poor neighborhoods and particularly backward caste villages. When government is installing community wells, as Chander just mentioned, that government is putting a lot of efforts in providing piped water, but it's not always possible to maintain them, and you see very costly equipment lying there, but they are just lying there. So if the government is anyway going for community wells, same sort of traditional wells, then they should provide them at stretched locations. For future research, we would like to look more into like how this market-based approach will increase penetration of arsenic well testing, and next is the changes in behavior. And second, like, is there really a caste-based reason about the less switching, which we observe in Bihar? How can more switching to safer wells be encouraged, like a public awareness campaign or some sort of cohort program which I mentioned? The other areas which we are looking into is Punjab in Pakistan and India, Bihar and Uttar Pradesh right now, Bangladesh and Myanmar. Thank you.
Thank you, Jay. Thank you, Prabhat and Chander, for a very good research study. And this is very timely because we have projections that NCD non-communicable diseases are going to take a big toll, and so this needs to be addressed. And in this study, one of the things that are highlighted here is that 34% of the community wells had arsenic levels that were greater than 50 micrograms per liter. Now, from the policy perspective point of view, we need then to address this, that the community wells which are dug need to have arsenic levels below 10 or 10 or. Now, in this case, how does the government intervene? Do we have the subsidy, at communities and wells, do we have to subsidize that component to create the access for the backward castes who are not switching? That is one aspect that we need to see. The second one is that the study has brought out that only 28% of the households claim to be aware of the status of their well. So, from the public policy perspective, we need to generate awareness in this area. The third aspect is that the study has brought out is that rupees 20 is a threshold limit at which households are willing to pay. But at rupees 20, we are also subsidizing the wealthier households who can pay a higher amount. So should we have a graded fee structure so that the subsidy component is restricted, greater subsidy component is restricted towards the lower and disadvantaged group. The third aspect is that we have looked at the supply side, that okay, here's a kit which we will test at a fee of rupees 20. But what about the demand side barriers? We need to address that also. Is access, even if we provide this kit at rupees 20 and it is subsidized by the government, is the access there to having used this kit to switch? Does the community center wells are distributed in a correct, geographically, so that the disadvantaged groups have access to these community wells? And the third aspect is that the availability of the toolkit, along with a reasonable fee, will it, should it be packaged along with a remedial solution? Just providing the toolkit and providing a fee structure there may not lead to the problem being addressed. So these are areas which we could take forward from this study and build on. With this, I will hand it over.
Thank you.